Here we have a SAT math problem. Okay, let's go to the question. The XY plane above shows the graphs of two quadratic functions and a rectangle. Points A, B, C, and D lie on the graphs of y equals to x square and y equals to negative x square respectively. If the area of rectangle ABCD is 108, what is the length of BC? So we have to find the length of this line segment BC over here. Okay, for that, what I'm going to do is I'm going to consider the point C on the graph of y equals to x square. At the point C, let me consider the x coordinate as k. Then what is the y coordinate? So to get the y coordinate, what I have to do is I have to plug in this x coordinate k into the equation of the graph over here. When I plug in x equals to k over here, then I'm getting y equals to k square. Okay, here since the x coordinate is k, the value I have on the x-axis over here has to be k, and also since the y coordinate is k square, so the value I have on the y-axis over here is k square. Otherwise, we can consider the length of this vertical line segment. This is given by the y coordinate over here, that is k square, and also the length of this horizontal line segment is given by k. And here let's consider the point D over here. So point D, what is the x coordinate of the vertex? Already we know that corresponding to the point D, the value on the x-axis is k, so the x coordinate has to be k. Then to get the y coordinate, we have to plug in this x coordinate k into the graph of the equation y equals to negative x square. When I plug in this x coordinate k for x over here, I'm getting negative k square as y coordinate. Okay, since the y coordinate is negative k square, the length of this vertical line segment over here is just k square. So the same y coordinate should be taken as positive because I consider the length over here. So what is the total length of this CD? So here we have k square, here we have k square. The total length is going to be 2k square. And also, since the length of this line segment is k, this one also will have the same length k, because this one and this one are parallel, because ABCD is a rectangle. And also here for both the parabolas, we have vertices at the origin, and y-axis is the axis of symmetry. Since the y-axis is the axis of symmetry for both the parabolas, so the points B and C and the parabola over here must be at equal distance from the axis of symmetry y-axis. Already we know that the point C at a distance of k units from the axis of symmetry, then the point B also must be the same distance, that is k. Then the length of this line segment BC is 2k. So according to the question, we have to find the length of the line segment BC. Now I got the length of the line segment BC in terms of k. Once I get the value of k, I can plug in the value of k over here, and it has to be multiplied by 2 to get the length of the line segment BC. Okay, now let's consider the rectangle ABCD. In this rectangle ABCD, this BC represents the length of the rectangle and the CD represents the width of the rectangle. Okay, we have the area of the rectangle. What is the area of the rectangle? Let me write the stuff over here. So area of the rectangle is given in the question itself. What is it? So that is 108. Let me write over here, 108. So the formula to get the area of the rectangle is length times width equals to 108. We know that the length is the BC, the line segment over here, that is 2k. So for L, we can plug in 2k, and the width is given by this vertical line segment, that is CD. So we got the length of CD in terms of k, that is 2k square. We can plug in 2k square for W equals to 108. Okay, 2 times 2 is 4, k times k square is k to the third power equals to 108. Okay, now let's solve for k in this equation. Let me divide the both sides of the equation by 4. Then this 4 will cancel out. 4 goes into 4 one times, and 4 goes into 108 or 27 times. Let me continue over here. Then I'm getting k to the third power equals to 27. Okay, so since my aim is to solve for k, I have to get up this cube. So for that, I'm taking cube root on both sides. The cube root of k cube equals to cube root of 27. So this cube root and cube will cancel. I'm just getting k, and cube root of 27. This 27 can be written as 3 times 3 times 3. So in cube root, for every 3 same numbers multiplied inside the cube root, one number will come out. So here we have 3 is multiplied by itself for 3 times. Since it's a cube root, for these 3 3s, 1 3 will come out. Now I got the value of k. K is equal to 3. But our aim is to find the length of the line segment BC. Already I got the length of the line segment BC in terms of k, that is BC equals to 2k. So now to get the length of BC, we have to plug in this 3 for k over here. Then I'm getting 2 times 3. Then we get 6. Okay, now I got the length of the line segment BC. So it is equal to 6.